Morning, class. On the front page of this, me and Ms. Potts put together a review packet on linear equations. So all of this is going to be stuff we've done. This review includes some notes. However, you can look at notes in your binder. You can use anything we've learned all year. Skip around if you need to. Where it says turn this into the end of class, because the computer lab was used Friday, the rest of the class didn't do UpSmart. They just started on the packet, so they're going to finish it today. You guys at home, just do as much as you can, and this video will be the answers, okay? So, go ahead and work as much as you can. Go through the notes, read through, and work the problems. After you have worked it, then you can continue watching these videos, okay? So until you've done the packet, or at least tried the ones you could, push pause on this video and then push play on this one and the rest of them when you're ready to see answers, okay? So push pause now. Alright, so I'm assuming you've already worked it. Let's look at the first page. It says proportional relationships. Proportional relationships will have a constant rate of change. And remember, rate of change is your y over x. This is also your slope, right? The change in y over the change in x. And you can do that by just adding or subtracting. Now, for them to be proportional, they've got to have two things. The ratio has to be constant, and it has to go through 0, 0. All right? That has to be a point on there. Now, from 9 to 18, this goes up 9. From 1 to 2, it goes up 1. So these are my y's, these are my x's. So they've got 9 over 1 for the first one, comes out to 9. 18 over 2, which comes out to 9. 27 over 3, which comes out to 9. 36 over 4, which comes out to 9. And if you follow the pattern, if we go back 9 and back 1, we would end up at 0, 0. So this one is proportional. Now it says determine whether quantities described in the relationship are proportional. Explain or prove. Well, let's look at number 1. From 1 to 250, from 250 to 500, this goes up 250. 500 to 750, up 250. This one also goes up 250 and up 250. So that side is consistent. Let's check their x's. Well, this goes up 1, 1, 1, 1. Well, 250 over 1 is my ratio, because you always put your y's over your x's, right? And it is consistent all the way across. Does it go through 0, 0? Well, if we go backwards, if we go down 250, we'd go at 0. If we go down 1, we'd be at 0. So yes, this one is proportional. On number 2, my y is down here, x is here. That goes up 2, up 2, up 2, up 2. This one, it goes up 1, up 1, up 1, up 1. So the ratio of y over x is 2 over 1, and that is constant. So that part checks out. But at 0, it goes through 2. So this one is not proportional. Let's look at table number 3. Now I see a dead giveaway. I see a value of 0 for x, and the y value is not 0. So this one is also no. Alright, let's check over here. From 12 to 30, that goes up 18. This one, that goes up 18. This one also goes up 18. X's, this goes up 3. 5 to 8 goes up 3. 8 to 11 goes up 3. So 18 over 3 will give a constant ratio of 6. Now, 6 is all the way across. Now, we need to check to see if this would go through 0, 0. Well, 2 times 6 is 12, 5 times 6 is 30, 8 times 6 is 48, 11 times 6 is 66. All the ratios were the same, and according to our notes, that means this one should be yes, proportional. Now, if you graph this, we can go backwards. So each time it's going up, the reduce would be 6 over 1, right? So if we go down 1, so that should go down 6, and that should be 1. If we go down 1 more, it should go down to 0 and 0. So yes, this one is proportional. I'm going to stop right here. We'll continue with the next page in the next video.